Hello everyone and welcome to today's webinar. My name is Sharon Madar and most of you know me already. I'm an accountant executive here at Stratoscale and I'm excited to be hosting this session today. Today is our fourth session and we'll focus on how to run and scale database clusters in an enterprise environment, and we all hope that you'll find it very helpful. I'm pleased to introduce today's speaker, Liaz Kamper. Liaz has been with Stratoscale for over 5 years and is a member of our Cloud Architects team. He knows Symphony inside out. Now, before I hand over the mic to Liaz, I have a few items to cover about this presentation. First of all, today's webinar will take around 20 minutes, followed by questions and answers. And the webinar will be available on demand after the live sessions. We will be sending out the recording via email. Now, if you have a question for our speaker, please feel free to send it through the Ask a Question tab. We'll answer your questions at the end of the session. Now, if we don't get your questions answered during today's webinar, we will be sure to follow up afterwards. Your opinion is very important to us during this session, and we'll run a few polls to learn about more topics you would like for us to cover in our future sessions. So, without further ado, I'd like to kick things off by welcoming Liaz. Liaz, over to you.
Thank you very much, Sharon, and hi everybody. Welcome to the introduction to the DB clusters webinar, where we'll be discussing brand new features in Symphony. What we'll do in this webinar, we're gonna have a short introduction to the cloud native approach, just to keep things in context. And then we'll have another introduction to what is a NoSQL DB cluster. We'll go through Redis and MongoDB, Cassandra, and we'll create a Redis cluster, and then we'll connect to it and actually use it a little bit. Then we'll create a MongoDB cluster, connect to the MongoDB cluster, and hopefully we'll have some time to use this as well. Now, as I said, let's just put things in context. We have public clouds for quite some time now. And the whole point with public clouds is that they offer a large variety of services that are easy to use. And we've discussed several of those services in the past. We've discussed network in the VPC sessions. We've discussed compute. We're going to discuss load balancers, Kubernetes, container platforms, and so on. So they have many services. One of the most important services they have is database. So they offer these services, and it's very easy to consume using APIs, SDKs, and so on. So when we come to the enterprise environment, there's a big question mark of how we're going to consume all of this. You have several services on-prem that they offer containers and so on, but we don't have a fully managed environment that's offer all the services from a single NPI endpoint and with a single script, infrastructure as code, UI, you name it, you can create a whole application. So this is where Stratoscale come into the picture, because actually we give all of this in an enterprise environment. So let's assume I want to create a Twitter application. It is based on network, and then we have the compute. So for compute, for example, we can have the web servers running on compute. For application, maybe we can run Kubernetes or other container platform that will give us maybe the backend. But everything is volatile from all I said so far. So we need to have a persistence layer. And this is exactly what we're going to talk about in this webinar. Now, when we want to deploy this Twitter application, the whole point is we want to use a set of tools in order to do it. I'm going to use a UI, but we're going to offer you that in the poll. What I would like to discuss in the next webinar is how to do exactly what I'm doing today, which is databases. We discussed Kubernetes, but the whole point is that we want to allow you to use the ecosystem, the DevOps ecosystem, in order to do that. And that's exactly what Stratoscale brings to the table. We have the possibility to run managed open source services on-prem, and you can use the great DevOps ecosystem, Terraform, Ansible, and so on to develop that. So as I said, let's assume we want to run a three-tier application. Again, first tier is the web services, second tier the front end, second tier is the back end where the application actually run, and then I need a persistence layer. And the persistent layer is the DB. So most of you know the SQL, the schema DBs, which we will discuss, I think, in one of the few next webinars. We have MySQL, we have Postgres. These are schema based. They're not clusters, meaning we have master, we might have a slave, we might have some read application, but it's not a cluster of a database running in parallel. This is why we introduced the database clusters, the NoSQL database clusters. What do I mean by NoSQL? So it's not NoSQL, it's not only SQL. It's a database management system, okay? And it doesn't follow the rules of the relational, okay? The tables that everybody knows. This is the table of employee ID, employee salary, you join them, you query them, and so on. No, it's something that it's kind of schema free. You can decide for your own what is the schema of the database. And the fact that we're free from schema allow us to be more efficient in reading and writing and scale out easily. And scaling out, that's the whole point of being public, and being fast, that's the whole point of using cache and so on. So the pros of NoSQL is, as I said, it's easily scalable. The performance is usually better. It has a simple structure. Many of the NoSQL database, such as Mongo, that we will be discussing today, allows you to just put in the database and maybe think of later how you're going to structure it and how you're going to query it. Usually in SQL, you need to think in advance, what is the table structure and so on. And the cons, it's usually less robust. The mechanism is not as robust as in SQL, where again, you have master, you have slave, you have one point of write, and then there's internal replication and so on. And usually it lacks the reporting and analytical functionality of the SQL. So as I said, Symphony now offers three very popular NoSQL clusters. The first one is Redis. I think that's the most popular key value store, and it's very, very popular also for caching. Then we have MongoDB, which is very popular for big stores of data. And last we have Cassandra. Cassandra we've been with Stratoscale for quite some time now. I don't think we'll be able to discuss it today due to short time, unfortunately, but I think in the next webinar we'll be able to discuss Cassandra as well. So before we begin, I would like to hear more about what are you doing with DB clusters right now, and what do you expect from the next webinar. So let's give it like a minute for you guys to answer, and then we're going to come back. Okay, so actually the results point out that most of you don't use any DB cluster. That's great. That means you came to the right place, and you're going to realize it's very easy to start using those very popular DB clusters, and hopefully you'll be start using them soon. So let's have another poll. Okay. So what is the current level of development that you have with DB clusters, but let's say with any DB right now? Okay, so this poll showed that actually at least half of you then never tried DB or DB clusters. Again, I think that's great, because that means in this webinar you understand how easy it is to start and using those databases, and I think everybody needs databases in some way or another in the organization. So finally, I would like to know, what would you like to hear next for the webinars? We always follow the most popular answer, and that will be the next webinar, hopefully. Okay, ladies and gentlemen, after a very tight battle between Terraform and Ansible, we have a winner. Terraform it is. We're gonna have a Terraform session, I think, quite soon, because I have many things to show you regarding how can you manage and run a full free-tier application based on Kubernetes using Terraform, which is quite new, and I think that will be the next webinar. So let's continue with the presentation and go directly to Redis. So as I said, Redis is a very popular key value store. Okay, so you just put a key and you get a value back, but it's more than that. So it's developed into having a data type store. You can put hash, you can create a set, an order set, a list. It's very easy it's very fast. Okay, so performance is fast because it's based mostly on RAM. This also implies on how much data you can store, because you can have easily half a terabyte of a database, but giving a virtual machine or any machine half a terabyte of RAM is something very expensive. So we usually put it as an LRU cache in front of a database or in front of an application, and most of the time it is compared to Memcached. Memcached actually gains less popularity right now, and Redis becomes the de facto cache standard. And again, the performance is very good on the RAM, and it also allows persistence to storage. So even though you put all the data in the RAM, you can also persist it into the storage, and we'll talk later on exactly how you can also restore from that storage into the RAM the database. But you need to think ahead of how you describe your keys, because the keys is how you can store the data. If you store data under a key that you no longer using, you can access that data is no longer obviously accessible. So you need to think of that in advance. Again, it's a cluster, so the data is actually replicated across the cluster. There is a master node that I'll show you that in a second, and secondary nodes, and the master node will spread the data in the background. And internally, we will, if the master is gone, we'll replace the secondary with another master, and this is behind the scenes. We implement AOF, okay, so that's an append-only files recovery. That means we store all the input commands, and even if a node just fails instantly, that file is always consistent, and if it's not consistent, it's very easy to recover. So we can easily recover a lost node in the cluster and so on. Based on that, we have HA coming very soon. And right now, cluster backup is not supported, but we are working in it, so expect that in the roadmap soon. As for Redis tools that you can look for, well, the most popular that I'll show you today is the Redis CLI. The Redis Python client, again, is very popular. I've used it in the past, and it's very easy to implement and integrate into your code. And there are several third-party UI tools, which are pretty neat, and I used one of them, but we're not going to show the UI today. So let's have a very short Redis hands-on. First, just a quick reminder for the administrators. This is the administrator screen. Before you start using the engines, you go to databases and make sure that those engines are actually enabled. So they are active here. So you need to activate Mongo, and you need to activate Redis. Okay, so both of them are actually, I think, a mistake. The version is higher than that. But for MongoDB, we're supporting version 4, Cassandra 3.11, so that's enabled as well. And also make sure in the settings that your users can see the containers. So after you've done that, the user can go into databases, clusters. I'm using a default VPC. I have it obviously already created, but let's create a new Redis. So I'm choosing, again, Redis out of the possible engines. I can name it, okay? So I name it Liaz, for example. So before I will continue, I want to show you something about parameters group. So each one of those, just delete this one. So each one of those parameter groups is here. So if you want to use the default one, that's fine. If you want to change it, just duplicate it, run new Redis params, and after you've done that, it's very easy to go in and then just change whatever you see the value here. You can change. Okay, so you go and change those values. Okay, so I can change log level, max clients, which are very popular to change, and so on. So after I've done that, again to clusters, I'm creating Redis test, just see how easy it is. I'll choose what parameters group. I haven't done any changes. I'm just gonna go again with the default. Size, it's, let's say 15 gigabytes, and again, just since it's RAM, based on RAM, you need to give it something quite large. So let's TX large. Next, this is the subnet that's going to be attached to. That's the default port of Redis, and done. Ladies and gentlemen, that's the only thing you need to know about starting a Redis cluster. Okay, so, and that one will be processing. Okay, so let's go to one of those clusters are already created. So as you can see, I have several endpoints. 4, 8, 10, and 25. I'm referring to the IP. If I want to manage it, I'm going here. So let's see which kind of events, sorry, which kind of options do I have? So I can modify at least the name. I can extend it. Now, unlike Kubernetes and other things in Stratoscale, when you're extending here, the screen means which on what node, which kind of nodes I'm going to extend. So if I'm choosing here 2, that doesn't mean I have a 2-node cluster. I mean I'm extending it by 2, and these are the parameters that I'm extending. And I can also reduce. So here it doesn't say exactly which node needs to be reduced. So that's actually a UI bug that we're fixing. But I can say I want to reduce this one and just go ahead and super easy reduce it. Again, we're doing all the scaling, scale out, scale in. If you read online about Redis, you see it's very easy, or used to be very hard to scale it out and in, but you don't have a problem because we're managing that for you. So Once I've done that, I've got 4, 8, and 0. Now, important to understand, unlike SQL right now that has a single endpoint with certificates and so on, for Redis and also Mongo, it's only internal. So I already created a jump server here. I would like to put it in the UI. So if I'm connected to one of the hosts, it's very easy to put a -c that will redirect me to the master. And I'm just go set a D10. Okay, I was redirected to the master automatically. And if I can, okay, so the key is a D. And if I get a D, I'm getting a 10. Very easy. So by the way, the cool stuff, I can do 5 times increment a D, and a D is 15. Okay, that's it. So we don't have much time. Let's go very quickly to Mongo. So again, Mongo is based on the disk storage. Okay, so it's excellent for storing big data and querying large amounts of data. The input is JSON, like you see here. Just putting the JSON. The ID, by the way, is something that is usually automatically put by Mongo. And then these are like the comments for like you can store comments for a website, for example. So it's schemaless. I can put in whatever JSON I want in every stage, and then I can just query according to the last JSON I put in, and the schema is something that I don't have to commit when I'm starting the database. There's a very deep queryability, unlike Redis before, where I have to state keys, maybe a bunch of keys, a set of keys. Here I can actually query. So when we say that this is no SQL, it's not only SQL, because you can have some schema and query according to schema, and it is low performance relatively to Redis. So don't use that for caching. As for robustness, so we're actually using sharding in Mongo. So each one of the nodes is a full replica set. It has the router, which is the query for the incoming data. Config server actually store all the cluster metadata, okay, everything in all the cluster. The shard is the data, okay? And so I can kill whatever node I want, and the data will just keep on, you can still query the data because it is sharded and just keep on getting replicated. Make sure you have more than 3. Okay, so that's ideal to have more than 3 nodes, because it's using all kinds of calculation that's based on quorum. AJ, again, just like Redis coming real soon, and cluster backup is currently not supported, but look for it in the next roadmaps. I'll be using Shell, Mongo in the few time I left, few minutes, but there's a very large variety of SDKs for many languages. So again, let's go to clusters, clustering here. I'm doing my new Mongo. Again, you can choose parameter groups. Let's just go with the default. Number of nodes, make sure it's 3 and above, and you can go wild again. You don't have here to have like a large amount of RAM. Again, next, network. Am I creating Redis? Yeah, sorry, actually creating Redis. So for create, let's create Mongo. Same thing, my Mongo 2, number of nodes, go with 3. As I said, 50. You don't have to go wild with the RAM here. Large, next. Mongo must have credentials, so it's my Mongo for DB name, and let's go with admin. Don't tell anyone. That's it. And if I go and to something I already created with Mongo, okay, so I'm just gonna go for that. I'm gonna use the the Mongo shell. So it's username admin, that's on user authentication minus host. You can go MongoDB like this, and then just give it one of those, let's do 0.6, 72.31.06, and the port here is 2701, just like here, admin, and I'm connected. So I'm sorry I can show you more than that on Mongo because time is short. I want to give you guys time for questions. So that was it for Redis and Mongo, and I really like to hear your questions now. Okay, so the first question actually is related to instances, but it's a valid one. Will we support MS SQL? So yeah, it's called, eventually we're gonna support what's called the entitled database images. You can bring your own image of MS SQL, might be also other database vendors, and they will bring your own licenses, and will help you manage at least not at least, but most of operations for MS SQL. So yeah, that's my answer. Any more questions even regarding? Okay, another question is, can DB spread across sites? Well, instances can spread across sites. So when we'll talk about SQL instances, you can have master and slaves and read replicas spread across regions. So let's say regions. But clusters, no, clusters, just like any other cloud, clusters have to reside on the same region. When we support availability zones, it can be, I think it will be able to be spread across availability zones. Okay, so another question about MS SQL is whether we'll be able to bring a custom image. So I'm not sure about custom image, but yes, some sort of will be able to give you SDK, and you can upload actually your own engine. There will be some limitations, so I'm not sure it's going to be a custom MS SQL image, but let's talk about that in the near future when I have more information. Basically, we're going to have SDK for your engines with some limitation, and MS SQL as an entitled image that could be configured into some extent. Okay, so another question is, how often do you plan to update the versions? Well, versions of Mongo, Redis, and actually almost any other DB, both instances or clusters, are available almost every version of Symphony. We update at least the minor versions, but please pay attention that we don't update that automatically. There is an update button, at least for the instances, and you need to update the engine if you're running an older version of that engine. Okay, so another question is, which clusters can be operated by AWS APIs? That's a great question. So out of the three I showed you, only Redis is supported using the AWS Elasticache. Eventually, on the roadmap, you'll see a support for Elasticache, and then you'll be able to manage at least some of that Redis. Until then, in the next webinar, I'll show you some cool features where you can actually custom any object and Symphony into Terraform, and you can manage it as using submodels. But we'll discuss that in the next webinar. Okay. Okay, I'm sorry, I think I was muted for a second. So the question again was, can I use Redis in memory and storage based? So yeah, so Redis is in memory, and we do allow Redis to persist into the storage. Just make sure you have enough ratio between the storage and the in-memory, and you'll get the in-memory performance and persistent into the storage. I can assure you that the bandwidth of the storage is enough to cover for the queries. Another question is, okay, so can we replicate into AWS or second Stratoscale cluster? So for SQL, yes. If you're running an SQL, unfortunately, I don't have an SQL instance to show you, but if you are running SQL, so I will start maybe in SQL, and then you go into replication. So let's go here, test SQL, T2 large, doesn't really matter. Next, let's go next installation. For remote replica, you can put here whatever host name you like, okay? It doesn't have to be inside Symphony. It can be anything that is accessible to this cluster, and then you can replicate, whether it sits on another region, in the same region, or somewhere in the network where it is accessible. And then you can replicate. I hope this answers that question. Another question. So what are the current limitations? So no real limitations in terms of internal replication of the cluster. The only limitation, as I mentioned, is the fact that right now we don't have a cluster backup per se like we have in the instances, but we are working on that, so expect that in the roadmap. So let's wait a few more seconds to see if we get more questions. Okay, so thank you, Sharon. Thank you, everybody. I hope you enjoyed this webinar of DB clusters, and well, expect much more information about both DB clusters and Terraform and other goodies that we have now in the product. And I want to thank everybody for joining us. Thank you very much.
Thank you. Bye-bye.